Science. We're going to start at the very beginning of physics today, and we want to get to the idea of what is physics. Well, physics has long been considered the basic science. Well, why is it the basic science? Why do we consider it the basement of science? In other words, all your science is, as Rutherford said, all your science is physics or it's stamp collecting. In other words, if you don't know the physics of something, you're just talking about the facts of it, about this thing and that thing and this thing, but not seeing the connecting ideas behind all of them. So physics is very much the basic science. All right? The reason it is the very definition of physics. Physics is the study of the interaction of matter and energy. Well, can you name anything that isn't somehow fundamentally an interaction of matter and energy? Well, that's physics. So physics is the basic science. Now, we root this in a couple understandings that make up the amazing universe of physics. And these basic understandings, a lot of them can pull you in from the very beginning. All right? First of all, if I were to take you outside and show you the world around you and ask you if you could find the three magics, the three things that are truly magical around us, what would you do? What would you see? Well, the thing about stuff that is truly magical is it's been in front of you for so long, you no longer see it. If I take a pen and let it go, it drops. Now, I didn't throw it down there, I just let it go. Now, your third grade brain is right away saying, well, that's gravity. Good. Now let's advance the brain a little bit. What the heck is gravity? How come it fell? I didn't push it. Frankly, if I was sitting here and you saw nothing touch it and the pen just lifted up in the air, well, you'd be sure it's a trick or something because you know that doesn't happen. Why aren't we surprised when it falls? Nothing's pulling on it that we can see. Because we use the word gravity. Gravity makes us all kind of dumb. What is gravity? How is this unseen force grabbing something and pulling it to the ground? Okay, that is magic number one. Certainly an unseen force. Interesting. We should study that. What's the second magic? Second magic is a little harder to understand, baby. But when it hit the surface of this paper, it stopped. Why did it stop? Well, you might say, well, it hit that, and they can't both be there. And, well, you're sort of correct, but when we study subatomic forces and subatomic particles, we find that there's so little actual matter here that it really can't be the matter that's stopping it. And, in fact, it's not. What is stopping it? The electrons surrounding all the atoms of this pushed against the electrons surrounding all of the bottom stuff, and they repelled each other. And that's what stopped it. So what stopped it is, believe it or not, electromagnetism. Ooh. So you pick up a rock, you drop it, that's the first magic thing. The second magic thing is it hitting the ground and stopping. All right. So clearly some stuff we need to learn there. What's the third magic thing? Well, stand around outside for a few minutes and look around you. Anything that looks magical there? Anything at all. Go ahead, look up into the sky. Oh, you might want to shield your eyes from that really bright thing. What is that really bright thing? Oh, the sun. Well, you ignore that because it's the sun. It's been there forever. You don't really have to even think about it. It gives us light. How? Well, right away, we're in the world of the nuclear forces. And that's the other magic. Now, when I say magic, I'm not talking like a magic trick. I'm talking magic like this is beyond what we understand. The universe started with this, always had this. This is magic that was imbued into the universe at the moment of creation. We don't understand it. Not really. We can work with it. We know the physics of all these things exquisitely, but we don't really understand why they are the way they are, where they came from. So we can leave them as real magics. Next, let's talk about what the universe is made of, and that's kind of fun. The universe is made of three particles. All we see in the entire universe is just made of three particles. Well, what are the particles? Well, One of them is electrons. It is a fundamental particle. It makes up the negative charge we see around us. It's the outside of all atoms. It's really the only thing you've ever seen or interacted with is electrons. Well, what's the other stuff in an atom? You might be thinking protons and neutrons. Well, those are, in fact, made of more fundamental particles called quarks, and they're made of different combinations of up and down quarks. So electrons and up and down quarks are the three particles that make up everything, right? So the up and down quarks, electrons, three particles, the entire universe. Whoa, okay, that's pretty crazy. And to really start the idea of physics itself, we come up with three Greek philosophies. The first of the Greek philosophies, these are the things that really got us going in thinking in a way that could untangle the mysteries of the universe. The very first one is that there are no magic steps. That if you're trying to explain something, don't invoke some magic step that everybody can't see and experiment with and understand for themselves. You have to take things logically, in order, and no magic steps. Okay, good first. The next one is to produce models, and generally mathematical models, of what it is you're talking about. If this happens, then this happens. But at what rate? How do the numbers work out? So, no magic steps, mathematical models, and a pretty important one. If it disagrees with observation, it's wrong. Well, those three ideas, these three particles, and these three magics, are really what this is all about, and how we're going to put it together. And right now I'd like to have you listen to a brilliant gentleman talk about the scientific method. All right? That's the rules of the scientific method. And this gentleman is one of the most famous scientists. This is Richard Feynman. So let's listen to Feynman in his own words.
Now I'm going to discuss how we would look for a new law. In general, we look for a new law by the following process. First, we guess it. Then we well, don't laugh, that's really true. Then we compute the consequences of the guess to see what, if this is right, if this law that we guessed is right, we see what it would imply. And then we compare those computation results to nature. Or we say compare to experiment or experience. Compare it directly with observation to see if it works. If it disagrees with experiment, it's wrong. In that simple statement is the key to science. It doesn't make a difference how beautiful your guess is. It doesn't make a difference how smart you are who made the guess or what his name is. If it disagrees with experiment, it's wrong. That's all there is.
That's all there is to it. If it disagrees with experiment, it's wrong. So you can see the rules of the scientific method are not as hard and fast as you might think, but this idea, built on its basic Greek philosophies, is what has gotten us all this amazing information that we have figured out by using physics. Look at the world around you. It has been changed completely because of the physics we use. Thank you.